The first question asks us to calculate the length of AC and AB. So we use the distance formula, and so I'm going to do AC first. So what we can do is we can say that this is point number 1 and this is point number 2. You can do it the other way around, it doesn't really matter. And so the distance of AC would be equal to, and now I just fill in the formula. So 2 minus 3 plus 1 minus 4, and then square. Go ahead, type that in. And to 2 decimals, that will give you 5.83. Okay, so let's just say AC is 5.83. Then we're going to do the distance of AB. So I'm going to use that as my point number 1, and I'll use that as my point number 2. And I'm actually going to write it over here. And so if you fill in the formula, it's going to be minus 2 minus 3 plus minus 3 minus 4. And if you calculate that, you get 7.07. The next question for 6 marks says calculate the median. Now remember that a median is something to do with triangles. So if I have a triangle over here and I go A, B, C, and let's say they call it median BF. So what that means is that it starts at B, and then think of the letter M. I want you to remember midpoint. So it goes to the midpoint of the opposite side. So if you had to look at the midpoint of AC, maybe it would be somewhere over there. And so if you had to connect it, it would be something like that. Okay? And this angle over here does not have to be 90 degrees. If it is, great. But if it's not, that's fine. A median does not have to be 90 degrees. Okay? And so this line over here, this line is what we call the median. So what they're saying here is that they want the median of triangle ABC starting at point C. Okay, so it starts at point C, and then it would go to the opposite side, and it would connect that opposite side at its midpoint. Now that midpoint would probably be somewhere over there. We'll have to calculate that point probably. And then that line that connects them, that is the median. Okay, so this is the median. And we want to find the equation of that. And so we know that it's y equals to mx plus c is the equation of a line. Now, we do not have enough information. We've got this point, but we need to know this point. But luckily, because it's a median, it means that it's at the midpoint. So we just need to work out the midpoint of AB. So the midpoint formula, let me get that for you, is this one over here. I don't know why there's no equal sign. It should be an equal sign over there. And so to find the midpoint of AB, I'm going to go midpoint of AB. I'm going to use this as point 1 and this is point 2. And then you just fill everything in. So that's going to be minus 3 plus minus 2 over 2. And then 4 plus minus 3 over 2. Then I'm just going to type this part on the calculator. And that's going to give us negative 2.5. And then this one over here would give us 0.5. So now we have some more coordinates. So we've got that one as negative 2.5 and 0.5. So now we can easily find the equation of the median because we can work out the gradient by using the gradient formula. And so I'm going to keep it as point number 1 and point number 2. And, oh no, we don't want the gradient of that. My bad. We want the gradient of the green line. So let's call that point number 2, and we can call that point number 1. And so we can just go fill in the formula now because we're trying to find the gradient of, oh, we don't even have the letter. So let's just call this the median, the gradient of the median. And so that's going to be 0.5 minus 1 over minus 2.5 minus 2. Go ahead, let's calculate that. And that gives us 1 over 9. And so we can say y is equal to 1 over 9x plus c. Now to find c, we need any point on that line. So you could substitute this point in, or you could substitute that point in. I'm going to plug in the 1 and the 2. So the 1 is a y value, and the 2 is an x value. Then if you go calculate c, you would get 7 over 9. And so that equation will be y equals to 1 over 9x plus 7 over 9. So that was quite a lot of work, but it's for 6 marks, which is awesome. Next question, calculate the angle of inclination of AC. So what is an angle of inclination? Let me give you a quick summary or a quick reminder. So if you have a horizontal line like that, and then you draw another line, then the angle of inclination is this angle here on the right hand side. The angle of inclination is always the angle on the right. Sometimes we do need to calculate the angle on the left, but then they won't call it an angle of inclination. If it's called an angle of inclination, then by definition, it must be the one on the right. Even if we have a situation like this where you've got a horizontal and you've got a line, it's always the one on the right hand side. Okay. And so they want the inclination of AC. So AC is this one here. Now, you have two options. What some students like to do is they'll take like a ruler, for example, and they'll take it all the way back, and then they'll calculate the angle of inclination over here. Why do they do that? Because we know that angle of inclination is always relative to a horizontal line, and the x-axis is horizontal. Okay, but we don't have to do it like that. What if you just make your horizontal line there, and then you just calculate this angle here? Yeah, but Kevin, is that not different? No, guys, it's exactly the same thing. Let me show you. If I did extend this line back and I calculated this one, these lines are parallel. So these angles are always going to be the same because of corresponding angles. So you don't always have to go back to the to the x-axis. You can make any horizontal line. Okay, so whether you decide to choose this method or putting the horizontal line there, it doesn't really matter as long as you're calculating the angle on the right, because they want the inclination. And so I'm just going to choose this top one. So when you hear the word inclination, I want your mind to instantly think of gradient. Inclination, gradient. Inclination, gradient. Okay? So we need to calculate the gradient of this line. And so the gradient of AC, we looked at the gradient formula earlier. I'm going to use this as point number 2. This is point number 1. And so that's going to give us 4 minus 1 minus 3 minus 2. And that'll give us 3 over negative 5. Okay. Now, I want you to also think of this. Gradient, inclination, tan. Gradient, inclination, tan. They all go together. Okay? Let me write that out for you guys. Gradient goes with inclination, angle, and that goes with tan. You know, like sin, cos, tan, these three are going to be used for analytical grade 11. So what we do now is we take this gradient, but we don't look at the negative. We only think about the positive. And we go calculate a reference angle. So we say tan minus 1, which is the same as saying shift tan on your calculator, and you don't put the negative, you just keep it as a positive. If your teacher uses a negative, then that's okay. Then they're using a different type of technique, okay? I have seen that once or twice. So that's going to give you 30.96. But now, to find the inclination angle, it's going to be 180 minus that. So you say minus 30.96. And you can see that this angle is quite a big angle. You see that it's a large angle, okay? And if you had to go calculate that, you're going to get 149.04. 149.04. And so I'm not sure where you want to fill that in, but I guess if we put it here for now, we might have to use it in a different way just now. But let's also just fill that in over here. Okay, for now that's the answer. Next question, the angle of inclination of line BC. Okay, so what do we say? Inclination, gradient, tan. So we're going to get the gradient. So we're going to go work out gradient of BC, which is I'm going to use this as 0.1 and this is 0.2. That's just my own choice. You can choose whatever you like. And that's going to be 1 minus minus 3 over 2 minus minus 2. And if we had to work that out, That actually gives us 1. Okay, now to get the angle of inclination, it's always relative to a horizontal line. So here we have a horizontal line, and so it's this angle here, because it's always the one on the right. And so if we had to go use tan, we'd say shift tan on our calculator, or if you use a sharp calculator, you would say second function tan, and you're going to put a 1, and that's going to give us 45 degrees. So it means that this little angle here is 45 degrees. Then it says calculate angle ACB, which is this angle inside here. So they want us to calculate that angle. Oh wow. Okay, so I see. So remember I said earlier we don't really know where they want us to show this angle, or where we're going to have to use it. So here we go. So remember we said that it's relative to any horizontal line, but if we extend it back to there, then we know that this is going to be 149.04 degrees, this whole angle over here, and we know that this is 45. So right here we have developed a triangle. And so in that triangle we could go and work out, so we could now go do a bit of maths, and we could easily get to this angle over here, just using angles on a straight line, angles on a triangle. Now what makes things a little challenging is that they haven't given us letters to call, well, we don't know what to call each of the corners of the triangle, for example. So when this happens, yeah, it sucks, I know, but it's fine. We can't, it's going to be difficult for us to describe, so just go do your calculations, and the teachers will have to just see what you're doing, okay? If there's no letters, there's nothing we can do about it. I'm going to quickly enlarge that green triangle. I want to just show you guys something. So we know that this angle here is 149.04, and we know that this is 45. Now, I know that a lot of you watching this, you would prefer to work out this angle using angles on a straight line, and then you would calculate this angle. You can do that. However, I'm rather going to use the other method, which is a bit faster, which is the exterior angle of a triangle. What that tells us is that this exterior angle is always equal to the sum of the two interior opposite angles. So that 149.04 is equal to this one and this one, plussed together. So we know that the 149.04 is equal to the 45 plus this other angle, which we don't really know what it's called, right? So I'm just going to, you see this makes it a bit difficult. I'm just going to call it C2, for example. And so we can say that then C2, we must give a reason for that. That's exterior angle of a triangle. And so if you had to work out C2, you're going to get 104.04 degrees. Then if you look at C1, or what they called it, is ACB. ACB is, you can make a straight line over here. And so you could say 180 minus 104.04, and that's because of angles, or angle straight line. Let's just say angles straight line. And so ACB should give us 75.96 degrees. 1.3, classify the triangle. So they mean like, is it equilateral, isosceles, scalene, things like that. So we can look at the lengths. So we already calculated that AC had a length of 5.83. We looked at that earlier. And then we looked at AB, which was here, and we said that that was 7.07. So we need to just quickly calculate the length of BC. So we'll just use the distance formula. I'm going to use this as 1 and this as 2. And so that would be 2 minus 2 plus 1 minus 3. And that gives us 5.65. So we can see that all three of these are different. So when the three lengths of a triangle are different, then it's called a scalene triangle. If two of them are the same, isosceles, and if three of them are the same, equilateral. Question 1.4. Determine the coordinates of D if Acdb is a parallelogram. Now, what's very important is that what a lot of students do is they just go A, C, B, and then they put D over here. But that's not correct, because they specifically said in this order, A, C, then it's D, and then it's B. That makes a huge difference. So A, C, and then D would have to be somewhere here. But if it was A, B, C, D, then D would be somewhere over there, because then it would also make a nice parallelogram. But they said AC, then to D. So that's very important, guys, that you look out for that. Now, how is this only worth 2 marks? It's because this is probably the easiest question, and they love asking it. Okay, I think I have drawn that a little bit wrong. It would be more like that. And there. Yeah, so it would intersect somewhere here, but it doesn't really matter. So let's just for now say that it's somewhere here, just so we can easily draw that. So what you do is the following. You're going to look at this coordinate here, and you're going to look at this coordinate here, and you're going to try and see how did the x values change, and how did the y value change when going from A to C. So when we went from A to C, what happened to the x values is that they went from -3 to 2. So they increased by 5. Then if you look at the y values, they went from 4 to 1. So that means the y value went down by 3. Now that is going to be the exact same thing that is going to happen when we go from B to this new point, D. It's also going to go up by 5 for the x and down by 3 for y. How easy is that? So if we look at B's coordinates, they are currently -2, -3. So we're just going to add 5 to that. So D would be, we're going to add 5 to this, which would become 3. And then we're going to subtract 3 from this, and that's going to become -6. And so the answer is 3 and -6, and the reason is called inspection.